sometimes it seems weird that in math we keep going over rules that just seem to just already make sense. And for example, if we wanted to find the derivative of the sum of two things, like x squared plus 3x, then you could take the derivative of each individually, and you're like thinking like, yeah, that makes sense. And that would give me 2x plus 3 in this example that I'm writing over here. So if you're doing the derivative of a sum, then you can split up the derivative of the sum, but it doesn't work for products. So if you see the product of two functions, that's the hardest part of this assignment, is identifying that there's two functions being multiplied together. If you see two functions being multiplied together, you got to go through the product rule. Notice it's f of x times g prime plus f prime times g. And I actually prefer to do f prime times g plus f times g prime. And the reason why is this resembles more the quotient rule. I should have found a picture that modeled it this way because I prefer this way, but both are the same because that plus sign. The quotient rule is going to have a minus sign, and that's why it's a little bit different. So let's look at this one. So derivative of the product of two functions, it's going to be f prime times g plus f times g prime. So let's identify what f is first. So f is x cubed. Now notice this is two functions being multiplied. X cubed times sine of x. That's the first thing you should do, is realize that we're multiplying functions together. So the answer is not 3x squared cosine. That's what our brains are going to think, 3x squared cosine at first thought, but that's not the answer. We have to go through the product rule. So f is x cubed, so that means f prime is 3x squared. And then g is sine. So g prime will be cosine of x. So let's go ahead and just put this together into the product rule. So we'll have f prime times g, so that's going to be 3x squared times sine x, plus f times g prime, that's x cubed times cosine x. In free response world, this is fine, which this question is free response, so you can leave it that way. That's great. In multiple choice, you may not find that way. You may find it this way, but you might also find another way. And this is why we have to see the structure in our expressions here, that we could factor out the x squared. So if it is possible to factor something out, you don't have to do it. But if you're in a multiple choice situation, you can't find your answer and you're sure you're right, it might be because you had to factor something out. So both these have x squared in common. Realize when you divide the x squared from the x cubed, it leaves you still with an x right there. This is a similar example. Just be careful with that e to the x and factoring it out. If we have more time, I'll go over that. So let me do one that's a little bit more complicated. So once again, quotient rule is f prime times g plus f times g prime. So let's identify f and g. So f would be cosine of x. So f prime is negative sine x. And be careful, that sign is usually what's going to throw people off, is that negative. And then g is x to the negative 2, so g prime will be x, negative 2x to the negative 3. Run it through the product rule now, so negative sine x times x to the negative 2. And I'm going to put the parentheses this time, because if you don't, it's going to make it look like it's all this is inside the sign. But this isn't inside the sign, it's outside of it. Because remember, you have the sign times this, not sign up. Remember, inside the parentheses is sign of that. And then we'll have plus f times g prime, so that's going to be cosine of x times, and I guess I should have put the parentheses around that x as well. So now simplifying this. That was easy. That's the calculus right there. That's the only thing that's calculus. We took care of that. That was the easy part. Now we got the hard part. So we have this here, the x to the negative 2. Let's bring this to the front. Let's bring the exponents to the front. That'll be a better idea. Usually we put this in before the trig. And for that reason of, remember, this is the input and this is being multiplied. So you want to bring this to the front so you don't get confused with this being inside the trig. So we'll bring it to the front. Commutative property of multiplication, that is okay to do. And then here we'll bring the negative 2 to the front, so it actually will become a minus. Now in a free response world, this is fine. You don't have to do anything. But in multiple choice, they might factor stuff out. So I can factor an x to the negative 2 out of both of these. A negative x to the negative 2, actually. And if you want, you could put the x to the negative 2 in the denominator. Same thing with this, can go into the denominator. And I forgot one last parenthesis, but you don't have to. We'll just leave it that way. Multiple choice probably wouldn't do that, and I've never really seen it put that way for these types of problems. So we last have e to the x. I think those are pretty straightforward, but we can go over one real quick. So here's f, here's g. So f is e to the x, meaning f prime is also e to the x. G is cosine of x, meaning that g prime is negative sine of x. So we'll do f prime times g, so f prime is e to the x times g is cosine of x, plus f is e to the x times g is negative sine of x. Now realize that's e to the x times negative sine x. This will become minus e to the x sine x. And then we can factor out the e to the x since that's in common. And there you go.